Πώς βλέπουμε το presentation, εντάξει. Θα βάλω να ξεκινήσει η παρουσίαση.
So, good morning, everybody. My name is George Kapetanis. I'm a research engineer at the Laboratory of Maritime Transport. And in the frame of the Train MOS courses, and specifically the Pilot Action 4, which deals with multimodality and efficient shipping, I will present this morning two issues regarding focus more on the operational side of shipping. The first one is concerning emissions legislation and market-based measures. This is a very hot topic in the shipping today. Not only for the NOx and SOx emissions that have been legislated some years ago, and the legislation is in force, but also regarding the greenhouse gas issue. Today it is the last day of our presentations for Train MOS, the presentations for NTUA. And initially was planned that we are going to have tomorrow, Saturday, a visit. It was according to the program that we are going to have tomorrow a visit to Port Piraeus. This has been rescheduled, and this will take place now on Monday at 9:30. And please take a note, it will be very interesting, and if you can, you are invited to come on Monday to this event. So, coming back to our presentations, as I said, the first one is dealing with emission legislation and market-based measures. I will first give you a short overview of my presentation. The first chapter deals with a short introduction to the marine emissions legislation. This is a chapter, a general chapter, dealing not with the greenhouse gases, that is mainly CO2, but also giving you an overview of the legislation and of the measures regarding sulfur oxide and nitrogen oxides, what is already in force. Now, in the second chapter, The second chapter focuses mainly on greenhouse gases, and the most prevalent greenhouse gas is CO2. In chapter 3, some theories giving generally concerning the market-based measures. What is a market-based measure and how it is applied in terms of the market and in terms of reducing an emission or achieving the goal of reducing an emission. In chapter 4, some basics in economics of the market-based measures is given. That means I will explain what is the marginal abatement cost, what are the mark curves, and in which economical and financial frame it is advisable from the operator side of view to apply a market-based measure. I mean, a market-based measure is something something that is often connected with an investment from the side of the operator or the shipping owner and ship owner. And these are some relations that have to be explained. In chapter 5, we deal with carbon coefficients, that are the coefficients we use to calculate the CO2 emissions from a ship. The marginal abatement cost is further analyzed, and the mark curves, that is what I already explained to you. And finally, in the last chapter of my presentation, the most prospective MDM proposals are going to be presented. I'm writing here prospective because there are in the last years there were some 10 or 12 proposals from different states presented to IMO and discussed. During the last year, there are 2 years. There are a lot of discussions about this proposal. Some of them have been retained and have been revised from the states. Some of them have been merged together, and some of them are withdrawn. Anyhow, the discussion is going on, and so I will present 4 of them that I think they have the relative chance to be applied in the near future. Anyhow, the current situation is now that with the fuel prices of generally, but also for shipping so high, it is at the moment not so probable that that the main market-based measure will be enforced. Nevertheless, the discussion at IMO is going on, and therefore I will present these four MDM proposals, namely the International Fund for Greenhouse Gas Emissions from Ships, the so-called GHG Fund, the Global Emissions Trading System for International Shipping, a proposal by Norway, the Efficiency Incentive Scheme, that is a proposal under the category I mentioned before that has been merged with another proposal. It was originally a proposal from Norway, I think. And it has been consolidated with the proposal of Japan, and therefore in 2011 this consolidated proposal has been resubmitted. And finally, the modified ship efficiency trading proposal by the United States. This is also a proposal that has been initially proposed by the USA and then has been revised and resubmitted. So, the introduction to the marine emissions legislation concerning sulfur oxides and nitrogen oxides. As you surely know, emissions from ships are lately under the focus of legislation. In 2008, the Marine Environment Protection Committee of the IMO, the International Maritime Organization, has adopted the MARPOL 6 regulations that mainly deal with SOx and NOx. So the situation is now, and for the near future, for shipping concerning SOx and NOx, the following. As from the 1st of July of 2010, the sulfur content of marine fuel in the sensitive emission control areas, named SECAs, will be further increased from 1.5 to 1%. That means this is already in force from 1st of July of 2010. It was up to then it was 1.5%. And this is now decreased to 1%. The SECAs are control areas, specific sea areas, where IMO and thinks that they are very sensitive regarding emissions and regarding the air pollutants generally, and so they have other limits than, for example, the oceans or the other areas. These SECAs are now the English Channel, Baltic Sea, English Channel, and Baltic Sea, English Channel, and the North Sea. But the discussion is underway, and it is a matter of time that these SECAs are going to be extended also to for example, to Mediterranean. The areas not being SECAs have currently the limit for sulfur of 3.5%. But this we will see. So now, as from the 1st of January 2005, the sulfur content in the fuel regarding SECAs will be again decreased to 0.1%. This is a very big 10 times less than it is currently is the case. The SECAs are, as I told you, the Baltic, North Sea, English Channel, and that is what is the legislation planned and now for the current situation for the SECAs. For the other areas, from the 1st of January 2012, the fuel sulfur is decreased from 4.5% to 3.5%, and from the 1st of January 2020, this fuel sulfur content will be again decreased to 0.5%. This is, as you see, also a huge decrease, and as you can imagine, this imposes operational problems to the ships and to the ship operators, because for such a big decrease of the sulfur content of the fuel, they cannot continue to use the heavy fuel oil, and they should start to think using alternative fuels to meet these limitations in the sulfur content. This latter decrease, this decrease in 2020, because of the problems I mentioned, this could be shifted 5 years later, if the expert committees acknowledge that there are problems and that there are and mainly that in the market there is not enough fuel with 0.5% sulfur. So beside the legislation we have from IMO, also EU poses some legislation and directives regarding SOx. So as from the 1st of January 2010, all ships in EU ports with a port stay longer than 2 hours should utilize a fuel with sulfur less than 0.1%. except of the greenhouse gases and SOx and NOx, there are of course another emission in the exhaust gases of ships, particularly in the exhaust gases of diesel engines, are the particulates which we know also from Athens and from cars, which create, especially in a port, in the vicinity of a port, a big problem. This can be eliminated or is dealt with by using filters and better quality fuels. And anyhow, the particulate matters, which is very eminent in at ports. For example, if you think about the port of Piraeus having this problem, a very good solution for actually for this matter would be the use, of course, the use of better quality fuels, but also the so-called ironing, especially in Piraeus, where we have a lot of passenger vessels. This means that we will see it later in this presentation, but a few words only. Cold ironing means that a ship with has a longer port stay has the facilities to, the port has the facilities that the ship could not should not use its own diesel generator for electrical power, but she could use electrical power from the port. So this is one solution to not only for the particulate matter, generally for environmental friendly port stays of the ship. So here we have the emission legislation regarding fuel content, sulfur content in the fuel, and this is actually what I have explained to you, but in a more practical and graphical way, and it is more easy to understand. We have the black curve is the global one. This means the global limitation. The global limitation, not referring to SECAs. As you see, 2008 we had, till 2011 we had a sulfur content in the fuel for 4.5%. This goes down now from has gone down from the 1st of January 2012 to 3.5, and it will further decrease. And that is, you see, this is the big decrease, which creates some major operational problems to shipping. This should be further decreased by 2020 or maybe 2025 to 0.5%. The red curve is the sulfur content of the fuel and its development for the SECAS. It was initially 1.5%, it dropped to 1%, and finally, as from 2015, it will further decrease to 0.1%. These graphs are taken from Wärtsilä. So, here we have, in this graph, we have a comparison of typical NOx, SOx and particulate emission in relation of the fuel type. So the red or orange one bars, the bars are for heavy fuel oil, and the gray ones are for gas. This means for gas, this means in a dual fuel engine. These are engines that can burn diesel and LNG, for example. So, you see that for NOx emission, the gain we have or the decrease we have in NOx is the NOx produced by a gas engine is 10 to 15% of that of a heavy fuel engine. Heavy fuel oil engine. SOx is actually, sulfur oxides are actually eliminated through the use of LNG, and also particulates are relative to the particulates of a heavy fuel oil engine, something about 0 to 5%. So we will see very briefly some measures to reduce sulfur oxide emissions and nitrogen oxide emissions, and then we will speak also about ways, technical ways to reduce greenhouse gases. I'm speaking now about, I make this discrimination between technical measures and because I will speak about policy measures such as MBMs. This is also a way to reduce or set a cap on emissions, but this is something very different. It is a legislation, something different than technological measures that affect the engine and in the end of the day, produce a more efficient ship. So, for reducing sulfur oxide emissions, the first thing is that it is not correct the way I have presented it, because the first and most obvious way is the use of low sulfur fuels. I mean, SOx will be produced, and the SOx produced in the diesel engines are related to the sulfur content of the fuel. So the first thing and obvious thing we can do for reducing the sulfur oxide emissions is to use higher quality fuel, and low sulfur fuels have in most cases lower viscosity than the ordinary fuels, and this will affect the behavior of the fuel injection systems in diesel engines. Therefore, and if we are speaking about this big gap of the decrease that is planned, therefore we cannot actually take a low sulfur fuel. That is, if we are burning heavy fuel oil in our installation, we cannot simply take marine diesel oil or marine gas oil with lower sulfur content and operate the engines just like this. There will be we will need some modifications in the engine and in the injectors mainly, and also in the boilers and generators. The other way of reducing sulfur oxides is the use of marine scrubbers. There are a lot of techniques are under development. Also scrubbers have been built and also are in use, but a main problem with marine scrubbers are firstly their relative high investment cost, and secondly that they need a lot of space and to be installed on board. And generally, it is not yet a mature technology, so that ship owners can invest in it. I mean, in shipping, every novel technology and so on should undergo a big reliability check before it is being applied, because it is actually the most obvious and thing that in shipping is needed. So, as I told you, when speaking about very low sulfur contents of the fuel, another solution would be the parallel use in the engine of heavy fuel oil and marine diesel oil, because as we have seen, if you want to operate also your ship in sensitive emission control areas, and you have to use a fuel with sulfur grade of with sulfur content of 0.5. It is not you cannot use heavy fuel oil. All major engine manufacturers and almost all ships, main engines of ships, use nowadays heavy fuel oil due to cost reasons. So the parallel use of heavy fuel oil, and so if you go in a SECA, you should switch to marine diesel oil or marine gas oil. For this, to have this possibility, you must install on your ship a separate tank for and piping system for the two different tanks, for the different types of fuel. And please note that this option you have for using marine diesel oil or marine gas oil in SECAs, it will be valid only until 2015, because after that the sulfur limit of 0.1, I think, %. Yes, after 2015, the sulfur content of the fuel would further decrease to 0.1%, and this limit can not be met by heavy fuel oil. So, and the last, another option for reducing the sulfur oxide emissions is the so-called ironing, which I have told you, I have briefly described in the beginning. That means during the port stay, the diesel generators are switched off and the power supply is affected through the terrestrial network. That means and requires, of course, necessary port infrastructure, which is currently available only in a few North European ports. Nevertheless, cold ironing is not always environmentally friendly, and because one must actually calculate and envisage the way power is generated in each country. For example, in North European countries where the electrical power is mostly generated through ecological ways, not involving diesel generators or coal or something like that. Substituting the diesel generator of a ship through the terrestrial network is of course environmental friendly. But for example, in Greece, where we have a big amount and percentage of the electrical power generated from coal, one should calculate this whole procedure and the emissions that are generated through this whole procedure, and relate that to the emissions that ships will have during their port stay. Anyhow, in general terms, it is a good solution, and the tendency is all over the world that terrestrial power generation is moving towards more eco-friendly procedures. So I think that cold ironing will develop also in other ports, and for example, as I told you, in Piraeus, for cruise ships and passenger ships, where you need a big amount of electrical power, and for longer port stays, it is obviously a good solution. We will speak now about reducing nitrogen oxide emissions. The new IMO NOx Tier 2 rules are active from 2011. The new NOx limit is 20% below the 2010 emissions level. In addition, a global restriction of sulfur content fuel will be limited from 2012 to 3.5%. Yes, in restricted SECA areas, a maximum sulfur content of 1% is in force from 2010. So the next emissions level, IMO Tier 3, will be valid from 2016. And this is expected to demand a further reduction in NOx level of 80% from Tier 1 level. Yes. An 80% NOx reduction requires a step change in terms of engine technology and product offerings, because you see that 80% is a very big decrease, and that means that major constructural changes in the engine and in the whole procedure of injection and fuel technology should be made. So the new solutions and changes that are envisaged for the engine manufacturers involve engine internal technologies, after treatment technologies, and fuel gas related technologies. So a parallel development of all these technologies will be needed, and in order to achieve this very ambitious goal of 80% reduction. So, in the after-treatment technologies, the selective catalytic reduction will play an important role, and also this catalysts are even today applied, but this will also further be developed, and it is essential to also ensure the good working and the good working combination of the catalyst with the scrubbers mentioned before. And of course, there are a lot of further development work to be done and accomplished in order to meet these rules. So we see here also graphically the emission legislation and in marine application of IMA, the revised MARPOL Annex 6 for NOx. The tier 2 graph is the red one, and the tier 3 graph for new ships is the 2016 is the black one. Here we have the development of diesel engine specific fuel consumption and NOx emissions. You see that both the fuel consumption and the engine and the NOx emissions have the trend to decrease. That is of course very good and very advantageous for a ship owner, because he mostly cares about the cost, and cost is related to fuel consumption. So let's speak now about the other major category of emissions, namely the greenhouse gases. Shipping is not yet included in the United Nations Framework Conference on Climate Change, and there is no reduction target for CO2 and GHGs. And in fact, until very recently, shipping was the only mode of transport that had no such limitations. This era of non-regulation went officially to an end in July 2011, when the MEPC of IMO adopted the EEDI, the Energy Efficiency Index, for new ships. But even with the Energy Efficiency Index in force for new ships, even so, this discussion is very hot lately, and it is going on, and more measures and legislation is sought for the existing ships. So the measures that we can use to reduce greenhouse gases, and when talking about greenhouse gases, we are talking about CO2. To reduce greenhouse gases from ships, these measures can be divided in three major categories. The first category is technological measure. That means, for example, more efficient energy-saving engine, more efficient ship hulls and designs, more efficient propellers, cleaner fuels, alternative fuels, devices to trap exhaust emissions, as I told you, scrubbers, catalysts, and so on. Energy recuperation devices, cold ironing in ports, and very fancy and new assisting gadgets like kites, sails, and so on that lately are very much under investigation, and everybody is thinking about putting something like that in a ship that would further decrease the energy demands of a ship, of the propulsion of the ship. The second category of measures to reduce greenhouse gas emissions are the logistic-based or operational measures. For example, the most obvious and known measure is speed optimization, or better, speed reduction. Because as we will see also later on, and in my second presentation dealing with emissions calculation, as we will see later on, the CO2 produced from burning in fuel in an engine is related, of course, to the fuel burn. And the fuel consumption has a cubic relation to the speed of the ship. So the first and most obvious, but also the most effective, by far most effective measure to on the spot reduce CO2 and generally emissions from a ship is simply to slow down. But we will see this slowdown has also other aspects that could not. They are not favorable for the operation of the ship and for shipping in general. May help. Second logistic-based measure is optimized weather routing. Optimized weather routing. This means This means also a speed optimization, taking into account the weather conditions, the sea conditions, and also not only the sea conditions, but also the condition in the next port and the condition of the cargo availability or not. Optimal fleet management and deployment. This means, of course, to optimize the cargo. To optimize the cargo on the ships and on your schedules. Efficient supply chain management and others that impact the logistical operation. And finally, the measures, the third category is the market-based measures, the so-called MBMs. From these measures, I also mentioned in my introduction, there were a lot that have been submitted. Nowadays, the discussion is going on, but it is also a little bit stuck with some problems also with small developing countries and concerning how to set the carbon price, how to set the monitoring, and how to put a levy or a cap on emissions and so on. Anyhow, as I told you, the most prospective MBMs that would be applied is the emission trading schemes and international fund based on a contribution in quote of fuel and a variety of other MBMs. Generally, there are two main categories of MBMs. The one is simply in the one category, most of them are dealing with cap, a levy on the fuel. And the other main category are emission trading schemes. That means a cap is a global cap on emissions, CO2 emissions is set, and then trading limits are in the market, so one can buy or sell these trading limits. Okay. Πού με κάνουμε.
Θα κάνουμε ένα παύση τελειωτικό διάλειμμα.
Όχι, θα κάνουμε ένα διάλειμμα. So we will make a small break for a coffee break for 10 minutes.
10 minutes, yes.
Okay, thank you.
ήχο. Ναι. Είμαστε.
So we are back again. I think we should proceed a little bit faster because we are running out of time. So the market-based measures was the first category. I have here a graphical presentation also from Wärtsilä concerning the development of the specific carbon dioxide emissions of the Wärtsilä engines for different type of engines and fuels used. And of course, you see that natural gas is by far the most ecological and the most the fuel with less emissions. So measures to reduce GHGs. I mean, we have spoke about the three main categories, and we are now considering, and we will go further and deeper to discuss and present some MPMs. Of course, the general comment is that the categorization in these three categories is somehow artificial because it is not one measure that is being taken. It is obviously, and in real life, most of these three categories mixed up, and the operational measures or other measures that are taken to reduce the CO2 emissions are actually a mix of all these three categories. So some basic theory, as I told you, market-based measures are instruments and regulations that encourage certain behaviors or market signals. In contrast to command and control regulation, market-based instruments have the potential to provide powerful incentives for doing this. For example, in our case, the control of the CO2. For example, an incentive would be for shipping that if you have, you meet, for example, the EEDI or an operational index for existing ships. If a ship or a ship owner meets this efficiency index, and he would have a more efficient ship, he will operate more efficiently, and the incentive for him is to actually save fuel costs. In parallel, of course, with absorbing less emissions. Credit programs where credit are assigned when a source reduces emission below the required level by existing source specific limits. And finally, in a cap and trade system, an allowable overall level of pollution is established and allocated among firms in the form of permits. That is what I told you about. This is the way that ETS programs proposals actually function. That it means that the cap and trade system is set for CO2, and then allowable limits are traded between shipping companies in our example. So the basics in economics we will leave it for now. So the carbon coefficient. As I already told you, there is a linear relationship between the fuel burned and the CO2 produced. And this proportionality is the carbon coefficient. This means we have a coefficient and we can calculate the CO2 emitted through if we know the fuel consumed. In the IMO study in 2012, the coefficient used was 3.15, and then through an update in 2009, a slightly lower coefficient was used. Also note that this coefficient is different obviously for different ship types. And the factor that IMO uses for EEDI reference calculations is 3.11. And for LNG, for example, as alternative fuel, the carbon coefficient, as you see, is much lower, ranging from 2.6 to 2.8. The marginal abatement cost is the cost that we need, to avert CO2, to take a measure to avert CO2. I will not be going in detail about this method of calculation. You can see it if you like to in my presentation that it will be available in the Trainmo site. The marginal abatement cost is calculated by this equation, and where delta G cost A is the total gross cost in implementing measure A. Delta CO2A is the total tons of CO2 abated by measure A. The price of fuel and the carbon coefficient. The negative term in the right-hand side of this equation reflects the saving in cost per ton of CO2 averted due to the fuel consumption reduction. This means that for any measure A, the marginal abatement cost for A can be negative if the price of the fuel is high enough. Measures for which delta G cost A is low, that is the cost for implementing the measure A, are also more likely to have a negative marginal abatement cost. Now, what means if we have a marginal abatement cost that is negative, that means that the ship owner will have an economic incentive to implement this measure without any legislation or something to oblige him to implement this, because he will, as I told you, he will have an economic incentive to implement this measure, because doing so, this would increase his profits. And of course, implementing this measure will have also the side effect that he will reduce his CO2 emissions. And of course, equally, and on the other side, if the MAC is positive, then the ship owner will not have an incentive to adopt it, and conversely, this measure has to be mandated. So the MAC curves are the curves that examine feasible measures to reduce CO2 and compute these measures, this marginal abatement cost for such measures. And here is an example of MAC curves computed by DNV. And MAC curves are directly dependent on the projected price of fuel, and the MAC curves can be very useful if one wants to evaluate the effect of a bunker levy on CO2 emissions. This is explained, it is explained by my presentation. This is the delta CO2 is the savings in CO2 emissions, and levy F is the effect that one has through imposing a levy on the fuel. So we go now to the final chapter of this presentation, where namely four MBM proposals will be briefly presented mainly by some flow charts that we have here prepared in the laboratory. So the International Fund for Greenhouse Gas Emissions is actually, the GHG fund is actually a levy that is imposed directly on the fuel. It was originally proposed by Cyprus, Denmark, and the Marshall Islands, and a global reduction target for international shipping is set, and emissions above this target will be offset by purchasing emission credits. Basic function of the GHG is that part of money collected can be used also for out-of-sector emissions reductions. And finally, the contributions will be collected either through bunker fuel price suppliers or directly via payment from the ship owners. Here is a small comparison between levy and ETS, what I already mentioned before, and we go to the flow chart of the international greenhouse gas emission fund. So the basic concept is to establish to establish emission reduction. Okay, this is what I have already explained to you. The input to the system is emission and revenues targets. Secondly, the level of GHG contributions per ton. And third, the distribution of the revenues collected. The main characteristic and advantages of the system is simple uniform system with low administration. This is because we have a simple form of levying the fuel directly. That means a ship owner will buy his fuel, and instead of $600, he will pay $800 per ton, and this $200 will be the levy on the fuel. Another advantage is certainty over emission targets. The budget is budget certainty for the industry. That is very, very crucial for shipping, because with a levy, for example, you know how the price of the fuel will be increased, and you can adjust your operations. Funds can be partly used for out-of-sector reduction. It is claimed as the most efficient incentive system. Okay. This is schematically how the system is working. We have the ship with a fuel supply. And the fuel is supplied. The ship is supplied with fuel, and this fuel has a levy. So the ship owner or the charterer, pays the GHG contribution directly to the bunker supplier during the fuel supply. Then the bunker supplier pays this contribution, forwards this contribution to the fund administration. The fund administration reports to IMO that the specific ship or ship owner has paid his contribution, and the fund administration uses this fund and issues carbon offset credits, climate change mitigation and adaptation fund contribution, and fund administration and operational costs. These are the main three categories where where the fund is used for. So so the bunker supplier through the bunker delivery node, the bunker supplies to the ship the fuel, and the buyer through the makes the payment, as I said, to the bunker supplier directly. The bunker supplier has the obligation in 7 days to register the bunker sale with the registry, and in 3 months the registry receives the contribution. And then a dock is issued for the ship. The global emission, the second is the global emission, the emissions trading system for international shipping. This MBM would set a sector-wide cap on net emissions from international shipping, and the number of allowances ship emissions corresponding to the cap would be released into the market each year, and can be traded among shipping operators. I will not go further in pros and cons. I will show you briefly the flow diagram. These are the main characteristics of the system, and here is it how it works. As you see, we have allowances quotas that are being traded in an ETS market. And this is also the main characteristic of an ETS system compared to the GHG fund or a levy system. The third one is the efficiency incentive scheme, the consolidated proposal with Japan. The characteristics of the system, are the main characteristic: a scale fee system according to which ships should improve their efficiency by X% below the average efficiency for the specific vessel class and size. This is an incentive. If the ship increases its efficiency below this limit, then there are some incentives given, economical incentives given to this ship owner, and so he has also an incentive. The second characteristic is that it does not contain a rebate mechanism using the EEOI. This is the Energy Efficiency Operational Index. That is something like EEDI, but EEDI is meant only for new ships. So IMO is thinking of something similar for using in existing ships. The objective is to achieve sector carbon reduction by inducing energy efficiency improvements on ships. The concept is similar to the GHG fund. The IES does not include global capping on the total amount of CO2 emissions, and the mechanism for energy efficiency improving concerns new and existing ships. So this is the flow chart again. this is actually how it works, and if it is, as you see, divided in new ships and existing ships. For the new ships, the EEDI threshold is the criterion on which the energy efficiency is judged, and for the old ships, the EEOI is a limit is set. And as I told you, there are incentives given that the ships should have a better efficiency, a lower efficiency by X%. This X% is not yet calculated, and we don't know yet how this the value for this X is. Finally, we have the modified United States proposal. United States presented their proposal for ship efficiency credit training, SEC, at MEPC 59, but then this proposal has been further evaluated and has been resubmitted. At the beginning, SEC used a design-based index to establish efficiency standards, but the revised proposal is seeking to develop standards based on the total fuel consumption. This is a more comprehensive indicator of the vessel's efficiency, since it contains both operational and technical measures. The revised proposal suggests now, this is this is the main thing about this proposal. It suggests a phased approach in 3 phases. Namely, the first phase is the data collection. The data collection phase, where because now the whole system is based on the total fuel consumption, this phase of data collection is very critical, because on this data collection phase, collecting consumptions and the other trip details from the ship schedules is very critical, because on this data the final assessment and will be based. The final assessment of the limitations will be based. Then the second phase is a pilot phase of application of the program, where fine-tuning will be done, and then the full implementation phase. So this is again the basic concept and the overview, characteristics, advantages and disadvantages of the system. And this is the phase 1. As you see, the ships will send to the administration, the ships and the ships offices, ship operators will have to send to the administration all the data concerning mainly fuel consumption and feed and this data to the administration, and the administration send it to the IMO. The IMO then sets the limits for the attained technical efficiency and the attained overall efficiency standards. And in phase 2 is the pilot implementation phase. Energy efficiency regulations and rating methods. Energy and rating methods will be evaluated. Ship operators have time to adapt their ship's operation to the new standards, to meet the new standards. And then the phase 3 is the actual implementation phase. according to which the ships will be issued by a certificate in categories A, B, and C, dependent on which level they are beneath the standards set, efficiency standard set. So this completes my first presentation, and we will go directly to the second one, because which I will briefly discuss with you, because we have a very short time. So I will present to you an emission and speed optimization tool for different ship types that we have developed in the laboratory for maritime transport. So it is, as I told you, it is a tool that calculates the emissions. As we have seen, the emissions calculation will be a very critical tool, a very critical issue for assessing the energy, and is a very critical tool for assessing the energy efficiency of a ship, of a company, of a journey, of everything. And it is used now to assess these things and to improve energy efficiency. And of course, in this respect, a very similar question and relative question, and concerning also the operations of a shipping company, is how to optimize the speed of the ships. I mean, there are a lot of approaches from different perspectives, and you can see this optimization problem as almost all optimization problems with from a different angle, but of course here it is mainly seen through the angle of minimizing emissions, ecological angle, and of course primarily through the view of minimizing the cost for the operator. So the modeling task consists of two distinct steps. The step one is the step one in the tool. It is the single ship emission calculation and ship optimization tool. This means a single ship is considered to operate in a defined route, and for this ship emissions are calculated, and the speed is optimized. The model uses assumptions regarding freight levels, bunker cost, capacity utilization, etc. And the output of this step is, as I told you, emissions calculation for both inbound and outbound legs and the suggested speed. Concerning the inbound and the outbound leg, I must tell you that this is different in the calculation. The calculation mainly is different for different ship types. For example, if you calculate this step for a tanker, The inbound leg is laden. The outbound leg is ballast. So we have here different data, different mainly fuel consumptions, and therefore different speeds. If we calculate and we envisage, for example, a Ro-Ro or container ship, a Ro-Ro ship or a container ship, we don't have this. We must calculate both inbound and outbound lengths with different cargo factors, utilization factors, because Ro-Ro, you cannot assume that on the outbound or return leg the cargo will be zero. So in step two of this tool, the annual emission calculation of a fleet segment is calculated. So performed. Fleet segment, the fleet is assumed to consist of n typical ships, such as those considered in the first step. The model now does not refer to a specific route, and the input is the annual ton-miles throughput of the fleet. The speeds for the inbound and outbound legs are the optimized speed that we take from the step one. And the output are here annual emissions, annual emissions, and operational characteristics. For example, fuel consumption, operational days in a whole year, fuel consumption, and for the whole fleet segment. This fleet segment, you can apply this fleet segment thing like that. If for example, you are a shipping company, you can calculate this step for your fleet of similar, let's say, tankers you have. But you can apply also this fleet segment. For example, we have made such runs with the tool. You can apply this fleet segment for example, the whole fleet of Handymax bulk carriers, worldwide fleet, and see the projected annual emissions, or how the speed goes down, for example, with increasing the fuel price, or putting a levy on the on the fuel price. So the general description of the model, it consists of main sheets. It is run in Excel. It consists of main sheets like index table of conversions. This is only an index, and the table you can see later. I will show you these tables, these sheets. A data sheet, emission calculation sheet, emission graphs, the optimizer speed, the optimizer sheet where the speed is optimized, and the results. And the sheets have some supporting sheets that mainly for the fuel, trade route, cost price, for the main characteristics of the main engine, and for calculations, one vessel calculations. This is actually the structure of the single of step 1. This is the single vessel approach. We have the, as you see, the index and table of conversion. Then the data sheet, the data required, containing tray route, fuels, cost, right, main engine, and all these sheets is all this data is performed and used for the vessel calculations and the speed optimization. And then the outcome is the emissions calculation and the emissions graph and the speed optimization. So there are some, as I told you, some will go very speedy through it. There are some icons of the different data sheets. Here is only the input and conversion table. You can see all the different units used and their conversions, so that the program is automatically conversing the units needed. So this is the data sheet. You see the trade route, distance in nautical miles from Ras Tanura to Yokohama, days at each port, ship information, maximum payload, and utilization 90%. Ship information, that is what I told, capacity utilization and maximum payload in tons, from main engine speed, fuel consumption, power, maximum continuous rating, the actual service speeds. That is the cubic rule for it is not always cubic, but anyhow. In almost all the common ship types, the cubic rule for the relation to speed to fuel consumption is used. Power is associated with fuel consumption proportionally. For auxiliary engines, we use also this, the tool uses also this data. And we have also a cost profile, freight rate profile. And on this, from this data, the emissions and the fuel consumption is calculated. The emission is what I told you before with the coefficients. The coefficients are used, but you must always keep in mind to use the right coefficients for the right fuel type. Depending on what you have diesel generators burning heavy fuel or marine diesel and so on. And of course, you have to also to add the percentage for the emissions that are the emissions that you are emitted in during the port day, where you have only the diesel generators, if you have the diesel generators run. This is again the calculations for emission. So the results are like this in the emission calculation sheet, and graphs of the emissions are produced. These graphs are for one-way laden voyage, for the round voyage with ballast return. In this case, because it is a tanker. In other cases, we have the ballast, the return voyage, but not in ballast conditions, in laden conditions, and also in an annual basis. So this is also the trade route sheet, where the trip duration figures are calculated, and also in this respect, the most critical thing is that voyage delays are also calculated, and voyage delays are very important if we like to introduce in our cost model inventory costs. Inventory costs are, of course, have a meaning only if you have a delay of the voyage. If you have a delay of the voyage, and so you should pay this. The operator should pay these inventory costs. Fuel sheets. This is the way that the inventory costs are calculated. So this is the optimizer sheet, and so the optimization is of the speed is done, as I told you, on a cost basis, and this is defined the suggested optimum speed by the program, so as to maximize this an objective marginal cost function. In the annual section, following parameters are being calculated. Okay, return voyage per year, gross revenues, gross cost, voyage cost, bunker cost, emission cost, inventory cost, margin, and cargo transported. So the margin is calculated gross revenues minus gross costs, and the objective function is gross revenues minus gross cost minus inventory costs. This inventory costs we have done some runs of the tool and compared them with and without inventory costs, because okay, inventory costs are not always calculated, and also in real life they are not always regarded. So these are also calculations about how we calculate if we have the spot rate or the TCE, how we calculate if we have the TCE, how we calculate the TCE from the spot rate, or how we calculate the spot rate having the TCE. Time charter equivalent is the TCE. So there's also some calculation methods. So the speed optimization is done by a macro, and this macro runs all speed for laden and ballast leg with a range within the range we give as maximum and minimum, and it runs all the speeds in a step of 0.5 knots. And the results is the objective function, the TCE, the laden leg speed and the ballast leg speed. So you see here the results. The total max is in the right upper corner, and for this we have the speed, the optimized speed. So the fleet segment approach I have explained to you briefly, and here are some results. Fleet emissions graphs, and here are some results with a specific route, as you see, for VLCC tankers. These are the inputs. This is the fuel consumption and speed curve. Okay, and these are the typical ship and fleet attributes, and the results. The results for year 2009. Two different years have been compared to each other, with, of course, different spot rates, but different fuel prices. And of course the results, these are the results on fleet emissions and so on. The results were that increasing the fuel price, the optimized speed, which I explained to you, is optimized, focused on financial criteria and the cost savings. The average speed, the optimized speed goes down. So actually this is here also the method described for the similar method described for Ro-Ro ships, and which is actually the same, only including the ballast, the return leg is not a ballast leg. It is laden with a different utilization. So thank you very much. I have exceeded by far my time, but I think it was interesting for you. And I hope if you have, of course, any questions, I will be glad to answer them, and I will be glad to see you on Monday where we have a visit to the port of Tyros. Thank you.
We will continue in 45 minutes with our next speaker. So we have now a break. ήχο, παρουσίαση. Με ποια ξεκινάμε?
ISMT. Okay, thank you, Dr. Megalo. Right, sure. Okay. Siamo ancora to 3, ma si detto solo 4. Μάλιστα. All right. Μ' ακούνε?
Ναι.
Εσύ. Να μιλήσω.
Ναι, σας ακούνε.
Τώρα μ' ακούνε. Hello, good afternoon, and welcome back. We're going to spend a couple of hours here talking essentially from the viewpoint of the ship owner. So for most of the time, we are going to be talking, I shall be going to be talking, with a ship owner's hat. I need to do that because sometimes the viewpoint is very important. Reality is reality. One sees reality from this angle, the other sees reality from that angle, and reality is not a single thing. It is reality as you perceive it from the viewpoint that you see. So we'll say a few words this afternoon about the regulatory framework. As you know, shipping is highly regulated. It's perhaps the number 3 most regulated sector in the world, which are the other 2 more regulated, nuclear installations and air travel. And we are number 3. How it is done? It is done in a relatively simple way. There are producers of regulations, some of which are of international nature and others of regional nature. The region can be small, but can also be large. So, very quickly, international, as you know, is the IMO, which is the specialized agency of the United Nations for producing regulations for shipping. It is the ILO, which deals with the matters of labor. It is the Comité Maritime International, which is they are associate member to IMO, and they're producing legal texts, draft international treaties, etc. The OECD, and so on. We're going to be talking more about this. So at a regional level, those that I said earlier are the international. At a regional level, we have the International Union, the European Union, the American Coast Guard, flags. When I say flag, I mean country. The legal system of the country of which the ship flies the flag. The ship always is obliged under international law, international public law, to have one flag at a time. It can change from one flag to another, but never have 2 flags concurrently. Why is the question? And the answer is very simple. Because the ship comes under the legislation of the country whose flag flies. So if you have Japanese flag, the applicable law on that particular ship is the law of Japan. Okay? This is in principle. So we said regional producers are the European Union, American Coast Guard, the flags of nations, various institutional bodies of shipping, like BIMCO and ICS and ISF, and to a lesser extent, charterers. Charterers who want to somehow amend the carriage contracts to their favor. So they're introducing into the charter parties customized clauses to make their life easier and correspondingly the life of the ship owner less easy. So this is a side that produces legislations and, if you want, obligations, but there is the other side that somehow enforces. It's not the correct word, enforces, but it gives an idea what they do. They are actually those that make sure that the ships comply with their obligations. Okay? So the principal obligator to make sure that the ships are complying with the obligations are the flags. So whatever flag the ship has does have responsibility of what its ship does. It's not just the ship owner and the management company. It's also the nation whose flag it flies. The regional memoranda on port state control. Have you heard the word port state control before? Have you? Who hasn't? You have all heard about port state control, haven't you? All right. Now, can I ask one to tell me what port state control does? All right, let's have it quickly.
It is an agency maybe that makes sure that the ship complies with the international rules.
Okay, fair enough. It's something like this. The port state control authorities in ports, which are organized around the regional memoranda, make sure that ships that enter or leave the port of this country comply with fundamental international treaties which are regulating the environment. We'll come back to that. So regional memorandum, coastal states, when you're passing outside a coastal state, and there is, for instance, an accident or pollution, the country through the waters of which, the territorial waters of which you are passing, has a role to play, has a role in organizing the prevention and the cleanup, and its courts have the role of resolving the disputes, receiving the suits. And to the last bullet, which is classification societies acting on behalf of states or not. To issue certain certificates for the ship, the classification society, you know what the classification society is, right? Needs an authority from the flag to act on its behalf. For other certificates which are not of statutory nature, but of technical nature and verification, then the classification society does not need an approval, a license to do that. We do have a problem with a number of regulations that are thrown upon the ships every year, but we can do very little about it. Why? Because regulations in IMO are coming through the meetings of its committees. Every single member state has the right to submit a proposal in these meetings. So, if a certain state, for interests of its own, or of its producers, of shipbuilding equipment, for example, or for its shipyards, or for some other reason, environmental, etc., has an idea, whatever idea, to be discussed at IMO, all it has to do is submit a proposal. If it regards safety, it's going to be with the International Ship Safety Committee. If it is environmental, will be on the MEPC. If it is legal, we're on the legal committee, etc. Now, there is no way to tell these guys, don't submit, because it is the state that submits. Okay? It's political if you want. Now, does IMO discuss every single idea one country member is throwing on the table? No. There is a procedure. The procedure is that a proposal by one country has got to be seconded. Now, seconded means supported by another state. Now, once a certain proposal is put on the table and it is seconded by someone else, no matter if one is the United States and the other one is Ghana, immediately it goes into the agenda for discussion. And the odds are that once on the agenda for discussion, it will do the rounds, working parties, intercessional working groups, all kinds of working. It may end up into something, it may end up into something smaller. But it rarely vanishes altogether. Something in the end survives. Let me tell you a few things about the Memorandum on Port State Control. It may be useful, even if you know what it is about. Easier to see here are the regional memoranda in various parts of the globe. Okay? I have nothing more to tell you than this, and you will have the presentation in case you want to see them again. Do you know what the ISM code is? International Ship Management Code. Have you heard about it? You have. It's a thing whereby an idea of the Norwegians back in 1996, which was presented at IMO, seconded. It eventually ended up as a code. It started as a very big proposal, which looked like ISO. And we, with the help of others, managed to contain it. So it ended up as a slim document of 13 chapters. So among other things that calls for is a designated person ashore, which is a person that links the communication of the ships to the ship owner. For example, if a ship is asking for a spare part, it is the duty of the designated person ashore to tell the ship owner. Make sure that the ship owner sees that. Okay? If he doesn't, he has a personal responsibility for hiding this information from the ship owner. So his legal position is very difficult if something happens. So you'll see always the DPAs running after the owners to tell them this and that and the other, and at the same time, perhaps sometimes resisting ship owners not being particularly keen to listen to what they want to tell them, because what they tell them usually is too much or sometimes too expensive. So that ISM code makes a provision, special provision, about the critical equipment. And the critical equipment that the ISM code does is of particular interest to the port state control visits. Okay? And what are these things? Various, you can see in the second bullet. Essential bits of equipment of the ship to make sure it is running safely. Okay? So if during a port state control visit on board the ship, certain deficiencies are found, these are noted and put on a database in Saint-Malo in France, where there is this big computer. And when a ship is announcing its arrival to some other ports, the first thing the Port State Control Authority does is type in the name of the ship, and immediately it has in front of it all his history in the past. And what flags a certain port state control office to board this vessel, this particular vessel rather than any other vessel that calls in, is an alarming record of detentions. If you see the ship was detained here, there, you know it's no good. Second to that, multiple detentions comes port state control visits with a large number of deficiencies. So it went to this previous port and it had 32 deficiencies. Now a ship with 32 deficiencies is a ship with a problem. Now, even if these 32 deficiencies were dealt with before departure, because otherwise the ship would not leave the port, that rings a bell and says, look, this may be a ship with problems, with bad management, with bad crew, it's an old ship, or whatever. Okay. And if you have more than two, that is 3 and more detentions over a span, I think, of 2 years, you are chucked out of all EU ports. You are disbanded and disallowed to enter any EU port. Very serious matter. Very serious matter. Is there a way to go back and be accepted by the EU ports? The answer is yes. It is going to cost you dearly in time, in money, and in blah blah. So this procedure of allowing, obtaining again the permission to enter EU ports is something that it is painful. It's painful to the shipowner. So, are all international conventions checked by port state control? No. They are focusing on this that you see here. SOLAS, as you know, is for safety. MARPOL is for environmental protection, all kinds of things. Load line convention is how much you can load a ship. Collision regulations are 72. STCW 7895, which is how the flags issue competency certificates to ship officers who are able to do what. So it is the initials for standards of training, certification, and certification for watchkeeping. I have to close that. Give me 1 second. Να σε πάρω σε μισή ώρα. Thank you. So, let's silence this. Good. Tonnage measurement, how you measure the tonnage, and that has an impact it is of particular importance for ports, because this is how they are calculating the port charges. And Regulation 147 of ILO, because you've heard about this, maybe you haven't, it is the regulation that concerns how you build the accommodation spaces. It is minimum standards to make sure that people live in appropriate places. So what is presently and about to be amended is that 25% of all arriving ships in each port should be inspected every year in the EU. There are unified rules for ship inspections. We said about the repeated detentions, what the result it has. And all EU ports, not just EU, and others outside the EU, but in Europe, are linked online with Cyrenac. Cyrenac is a database. which is in France in a place called Saint-Malo, small port. This is where they're getting the information from. And certain types of vessel, high-risk ships, such as chemical carriers, for example, oil tankers and bulk carriers and passengers, etc., are subject to a restricted regime of inspections, either because they're carrying possibly damaging hazardous cargo or because they're carrying lives. This is what I said to you about that how you get detained and banned by the boats. And I'd like you to note bullet number 1. IMO is United Nations. And the United Nations can never oblige one of its members to do something. Cannot say ratify that or don't ratify that. All it can say is, I wish you would ratify that. Okay? So, really, it has got no teeth to bite. It can coerce the states to do something. It cannot oblige. Now that in the past has led to multiple problems, the biggest of which was the proliferation of substandard ships. You know what substandard ships is? You know what a substandard ship is? Substandard ship is what we could call, for your facilitation, a rust bucket. A ship which is ashamed to have, unpaid people, hungry people, rats going around, rusty, unpainted. You go up a ladder and you're afraid you're going to lose your life because you'll fall down, holes here, holes there, uninsured. Well, this used to be a situation of growing danger to everyone, including the ports. So how this was changed, and since 1981, today, we have arrived at a situation where substandard ships have almost disappeared. How? What was the magical thing that made them vanish? It was the introduction of post-stay control, an amazingly efficient device, which incidentally has come totally outside IMO. It has nothing to do with the United Nations and its shortcomings. It was regional agreements. The first one was Memorandum of Understanding on Post-Stay Control of Paris, 1981. And Greece was party to it, along with other 16, 17 European countries. And that has been copied in all other regions that I said in previous slides. So, I think enough is enough for this. I wanted to introduce you to the kind of operating environment as it has emerged the last 30 years in Europe. And that has got to do with the rest of our discussion this afternoon. Right. Can we do the coastlines?
Yes, good.
Γιατί να πας λίγο πίσω.
Ναι.
Γιατί εγώ έχω 100...
Ναι, εγώ το κάνω, σου πω.
Ποιο είναι το δικό μου?
Αυτό.
Αυτό είναι το δικό μου?
Ναι.
Οκ. Εσύ έχεις προσθέσει κάτι πράγματα σε εδώ, έτσι. Και μεγάλο.
Όχι, δηλαδή όταν ένα σαν PDF είναι μπορούμε να το ανεβάσουμε μόνο να αλλάξει.
Καλά. Να μην το έκανες PDF.
Ναι.
Α, οκ.
Να το ανεβάσω στο PDF.
Να το ανεβάσω στο PDF, that is correct. Right. What is coastline? This coastline. What is coastline? Okay. So coastline is basically what we say the coast. Here we're talking about coast. Surely what indirectly we are talking about is territorial waters. Bear with me. Coastal zones. Coastal zones means Aegean Sea, means Cretan Sea, means south of Cyprus Sea, means drilling rights, the right to drill for oil and gas, means fishing rights, means delegation of salvage rights, who's going to salvage ship, which of the two states, etc. The exploitation of oceans and coastal zones is central to what we call today globalized economy. And the exploitation of coastal zones is essentially a long-term economic development issue that has been of increasing importance over the last half century, and it is going to be even bigger. So all states have got their own coastline. The United States, Canada, Russia, China, Australia. The one and only place in the world that doesn't have a single coastline is the European Union. Now, how come does that happen? I must tell you that this has got a historical reason. As you know, the European Union started as a common market. When you have a common market, you have different states that have taken measures to introduce a common market. Common market does not mean a common state. The kind of organization, political organization of Europe is entirely different from that of the United States. So bearing this in mind, we see that the EU has a whooping long coastline, taking all the country members together, which is longer 5 times than that of the US, 6.5 times of China, 2.5 that of Russia. Huge area. This could be an asset that would play a most important role in the economic development of the region, Europe, and would create, in essence, a single market, as the obligation is from the founding treaties of the EU. So the idea was to see how this could be a single market. And what we see as benefit possible, that this would be common EU coastal waters, for shipping, trading, fishing, drilling. Common supervision, that part has gone ahead with the institution and operation of EMSA. I heard about EMSA. EMSA is the European Union's body in charge of safety and environmental protection. We bid to have it here in Athens, but it eventually went to Lisbon. And within this single area, we would not have customs formalities for intra-community cargo movements. Now you tell me, don't we have any? We do the simplified. Whereas, if you go from one state to another in Europe, the voyage is, as we said the other day, is international. Whereas, if you go within the territorials of one state, then it is domestic. Remember these two words, international and domestic. It makes a world of difference on customs procedures. And why is that of interest? Because customs procedures are time-consuming and expensive. And who pays for the time lost and the money paid? No one else than the receiver of the cargo. It makes for things coming in more expensive as imports, and it does for the goods going out more expensive than exports. It serves a negative favor to international trade. The more you make it difficult for the cargo, for the sea cargo, to enter and leave states, the more you actually assist road transport. Why? Because road transport has been fully integrated into one space. There is a single European market for road transport, for inland transport, the rivers, and for trades, and also for air. On the contrary, you don't have something like this on shipping. Why? Because the coastlines are each one of the country members having its own. Okay. Let's move on to see what the competition, the other trading blocs have been doing. The United Nations, as you know, has got the Jones Act. I'm sure it's not the first time you hear of the Jones Act. Have you? Do you know what the Jones Act is? Right. It says here, in order to trade coastwise, that is domestic voyages in the United States, you have to have a ship which has been built in the United States, has got American flag, and it is totally manned by American citizens. The strictest regime of it all. But you're going to tell me, but of course, the United States is all in favor of globalization and has been pushing for this, pushing for that, free. Yes. It's not for them, it's for us. They want ourselves to drop the protection of our economies while they're maintaining their own. I'm sorry, truth is truth and has to be said. So the most strict legislation on domestic transportation is in the United States. No other flag is allowed to move a single shoe from one port to another. Russia, the same. You cannot do between Russian ports with another flag. You've got to have the Russian flag. Okay? And this dates back to the days of the Soviet Union. China used to have a free-for-all regime in 1993. And what happened in 1993? In 1993, they started realizing that they had the ability to increase the number of Chinese flagships to the extent that they would be self-sufficient. They would not need anybody else to interfere. So from the moment they had the ships, poof, they raised the walls. And no other flag is allowed to trade coastwise in China, unless you have a special permission. And India has always been doing that. Anyway, Indian ships there. So the big question comes, why do we maintain this? How damaging is it? You see here that if you go from New York to Seattle, which means half the continent down and then up again, 6,000 miles, it is a domestic voyage. You still have minimal customs interference. I would say almost no customs interference. The ship loads, goes to the voyage, discharges, and this is it. It is domestic. In Europe, if you go from Pancras to Brindisi, as I said here, it's 250 miles. Okay? This is an international voyage. We even have cases of shorter distances. Going from Antwerp to Rotterdam. Shorter. Now, why are we doing that? Why are we doing that? We're doing that out of momentum. This historically always like that, was always like that. But we are in the age of the computers. We are not in the age of sales. Things have changed and changed and changed again, and we are still deep asleep. So there was a suggestion by a commissioner in 2008, 2007 and 8, whereby he said, yes, let's make it a single. And that was Commissioner Borges of DG Mare, the one that Ramanaki is now the commissioner. Okay? And that has been lobbying. Lots of lobbying. No, don't do it. We'll have problems, etc. And one wonders why. Why should ship owners resist to the idea of having a single coastline for Europe? It would make things so much simpler for them. So, my mind, I don't know that. The answer is I don't know. Right? What I can imagine is this. If you have a single coastline, then ships flying the flags only of EU member states will be allowed to trade in that. All other ships will need to have special dispensation license, it is called. Okay. So there were people, one had Singapore flag, the other had Panama, the other had the Liberia, etc., who presently are able to take a cargo from Hamburg to take it to Genoa. But if that goes ahead, they wouldn't. They would have to have an EU flag to do that. And there, I suspect, came the objections. So the Commission actually has done what it had to do, which was make a suggestion at the time. The owners have expressed their reservations, which according to my interpretation, was not correct. Alleging retaliation by who? Everybody else, all the major trading blocs are just like us, as we suggest. And of course, the short sea fleet is suffering. Why is it suffering? It's suffering because it has not got its own market, as it does everywhere else in the world. Huh? What? Something happens. Oh, right. Yeah. It doesn't have its own space. If you're in America, you have the American space. If you're in Australia, you have the Australian space. If you're in Russia, you have the Russian space, and nobody else fits in that. Whereas in Europe, to do the voyage from Patras to Brindisi, it's an international voyage. Anyone can do it. So you can have Russians, Indians, Turks, Canadians, you name it, free for all. Which means in turn that the EU ship has got to compete against all those guys. Well, what they did was this. When it actually came for discussion, they did not ask those who were about to be benefited, and who would benefit. Primarily would benefit the short circuit of the EU. And those were kept out of the discussion. They consulted instead the deep sea unions. And when you talk about the deep sea union, you're talking about all those guys using all kinds of flags of convenience. So they've blown it on the consultation, unless they didn't blow it, and they did it on purpose, that I do not know. But what we would have by then, we would be having common rules, which we don't have. And we still carry on carrying the burden of something that we should have done and didn't. This is one of the reasons why you see a slow progress going on in Europe. Slow progress. Okay? This was it. So, any questions on the coastlines? None. Very clear. We'll do now. It says the Lisbon presentation on the Lisbon 10 final. There.
This one?
Yep. We have talked so far about regulation in shipping. We have briefly seen port state control procedures, and so we see a regulatory framework, how in broad lines it works. We have mentioned the shortcomings of not having a single coastline around Europe. And instead of having measures to address these long outstanding problems, we have a new problem landing on top. And what is the problem? The problem is environmental concerns about the quality of air. Let me say first and foremost that according to my poor understanding, this planet does not have multiple atmospheres, it's only got one. Which means even if all the good efforts to improve that atmosphere are done in Europe, it doesn't really matter if in China or in Africa or God knows where they're doing the opposite. Huh? So, nevertheless, in order to be consistent with the declarations, the EU people said, okay, we'll push for adoption of a liquefied natural gas solution. We had the opportunity the other day to see how people from the side of organizers see on this problem. I would like now to see it from a different angle. And the different angle has to do with leaves. Why with leaves? Because leaves are those that are affected by acid rain. And the thing has all served for this particular time period the problem has centered on sulfur and its problems on leaves. Leaves, you see a leaf with acid rain, you can see it at the bottom. It's got holes blown in it, and the holes are due to sulfuric acid. Okay? And this sulfuric acid does that to forests. And as we said earlier, the problem is much, much more acute in northern countries than in the south. You can see what it does on statutes as well. It is eating away the stone. And if you go in a cemetery in England, for instance, you would see that most old statues in the cemetery having a face like that. Why? Because acid rain melts away the stone, while also damaging the leaves. The discussions about a global cap on sulfur go back to the 1990s. And then there was a last-minute intervention by Greece and China and the International Chamber of Commerce, which suggesting a sliding scale on the sulfur cap. This would last about 15 years. And in these 15 years, and gradually, the entire industry would have turned into less sulfur-using fuels. At the time, this was not accepted. And the reason why it was not accepted at IMO was a lot of background discussions and pressure by the oil companies. Why don't the oil companies want this? I'll tell you. Because an oil company loves to produce heavy fuel oil. In fact, if the oil industry cannot dispose in way of selling it, heavy fuel oil has got a big problem because it has got to find ways what to do with it. So instead of that, they said, okay, but we need time, so that was turned down. What happened then? What happened, we have a global cap set, 2020. But I'm not very sure it's going to go ahead. Nevertheless, let's see where we are. As you all know, we've got the 2015 with the special emission control areas. We call them SECAs. And we talked about the various technologies, two of which are considered scrubbers and LNG, but really, scrubbers are not quite ready. So the mere suggestion that these would be areas where obligatorily one should use low sulfur fuel has set in motion a game in which there are various number of players, each one with his own strategies, which keep bumping on one another. States, producers of fuel, LNG, bunkers, ship owners, states, environmental agencies, and the like. I have seen estimates on literature about the cost of retrofitting. This is a ballpark figure for LNG. It's not says how big the ship is going to be. The actual figure can be smaller. And the cost for retrofit is a little smaller too. If you go using gas oil with very low sulfur content, you don't have to do anything, not introduce LNG, not have a scrubber, but you're penalized. We're penalized as we see it today because gas oil is so much more expensive. Whereas when you use scrubber, you still use old heavy fuel oil. Is the scrubber a good solution for the environment? No, it is a second-class solution. The best solution by far is LNG. It is cleaner, it has no particles, etc. We'll see. But however, yes, it's a second class. but it is cheaper to fix, and it addresses the concern, the only concern at this time that was put, which was sulfur, and it does it well after the problems are resolved. When you have a ship, the number one thing you are concerned about is the worth of your investment, how much it costs. Now, whatever you put on the ship in terms of repairs, in terms of alterations, or whatever else, is immediately having an impact on the resale value of the ship. To give you an example, if you're trading in and out of SECAs, the question is going to be, how much would I tolerate to increase the cost of the ship in view of the fact that tomorrow I may have to sell it to someone who doesn't go in and out of SECAs? So the conversion for this particular buyer will mean that he is paying for something much more expensive than he needs. This is one of the big drawbacks of introducing these things on a regional basis. The measure would have a lot less distortions if it was a global measure. Globally, there are ideas of introducing it by 2020. However, I must tell you that in 2018 there's going to be another conference in IMO to reconfirm the date. And I'm telling you from now that they're going to give it another at least 5 years, as I see. Because they will have seen the kind of upheaval it has created in the SECAs which start in 2015. Okay? So why should I retrofit my ship? What part of it is going to be recoverable? Immediately, I'm ruling out from all the people who are outside the SECA. Why do it? The best thing would be option C. I will stay on gas oil as long as I can, and at the same time, I will be trying to sell, as is, and buy another one, if I want to stay in the SECAs. If I don't want to stay in the SECAs, fair enough. But I think the best bet is C. Now, if you come and see what percentage the retrofit represents to the ship value, we have some surprises. You can see bullet number 1. A retrofit costs about half of the ship value. For a 10-year-old ship, a 10-year-old ship is not an old ship. Okay. What happens to a small container ship? The figures are even worse. It costs more than the actual ship. Doesn't make any commercial sense to do it. Which ships are open for conversion then? From the existing ships only, the very, very, very new ones. And then again, those ships would also risk not to recover the full money of the conversion if sold to outside. Still, what is the position on the oldest and the bigger ships? Surprisingly enough, for a Panamax, the conversion of LNG is still half of the ship's value. and slightly smaller percentages for the Aframax. You may have noticed that all ships are 10 years old. The situation that today the crisis has brought the ship values down is making a difficult situation even more difficult. Because if the ship value was much higher, the percentage on its value would be lower of the conversion. But we have a situation where the bad has been made even worse. And see the last bullet, which says that regarding the investment, the percentages may be such. But if you start running a big ship with a big engine, all on gas oil, I mean, the impact of the more expensive fuels is multiple as compared to a small ship. So the option of retrofit is only for very, very young ships. Which ships? Ships that spend a long time in sectors. If you have a contract, time charter, and you are working 12 months a year within the sector, and the ship is fairly young, yes, you're going to do it. Now, what percentage of ships are in this category? Very small. Very small. Most ships go once in a blue moon in a sector. Okay? Others go more frequently, and a tiny small fraction spends their entire life within the sector. Okay. The rest will go on gas oil. Now, we are talking and making calculations, taking into account what we think the cost of running on gas oil is today. Today, that the demand for gas oil is small. But imagine when you start suddenly all ships calling in sector ports to require gas oil. The demand for gas oil, which is presently only for some passenger ships and generator engines, is going to go for main engines for everyone. It is going to be a few multiples or many multiples of what we know today as the market for gas oil. Now, if you are an oil company and suddenly you realize that there is a huge rise in the demand for the product that you're selling, which is gas oil, would you charge the same price? You wouldn't. You would say, hello, boys, welcome. We are going to offer you a good dinner, but you will pay for it. So that I don't expect the prices of gas oil to stay where they are, nor do the oil companies. Now, how do I know that? It's not just my logic telling me this. I was at a conference in Paris about a month ago, and I made exactly the same question to representatives of oil companies. They were there, Shell, they were BP, they were Total, and that. And two of them declined to reply. And one, which offered to give me a reply, talked for about 5 minutes without mentioning anything about prices. Said how good the company was and how good quality the products were, etc. Bullshit in English. Which means what? If he had something to comment, wouldn't he say, oh, no, we wouldn't. We recognize, we should respect the environment, we respect the environment, we're going to be providing and with equitable terms, perhaps a little rise, nothing. Now, if I were an operator and I saw this kind of response, I would worry very much. Which means I wouldn't be surprised if you see a 50% rise in the cost of gas oil, which is close enough now to $1,000 per ton. It's not funny. The numbers are huge. The money involved is astronomical. And of course, it is a bonanza for the oil companies. Okay.
And also the fuel oil prices.
Fuel oil prices, with the same logic, could go down. The heavy fuel oil. Heavy fuel oil could, in the region, certainly. In the region, certainly, because there would be no... But I don't believe they could, by lowering the prices, enhance its usage, because those that go to gas oil, they go involuntarily. They are obliged to do it. Doesn't mean that lowering the price of the heavy fuel oil would actually encourage them to go, because it's not a free. It's a regulated regime, obligatory for them. It's something they don't like. Nobody likes to go to the doctor. But when you go to the doctor, you go because you have to. It's an equivalent situation there. You have to buy that gas oil. So, we say a few things here in writing. I think we said it all here. But go to the last bullet, which says, hopefully the oil refining industry will be able to produce extra quantities of gas oil without introducing too much sulfur in the atmosphere. Can you imagine? Can you imagine? Restricting the ships from using heavy fuel oil, leading on to extra refining efforts in the refineries, and having the refineries through their funnels introduce sulfur in the atmosphere. That would be fun. That would be great fun. A total collapse of the logic of the entire exercise. You've heard about green corridors. If you haven't, doesn't make much of a difference. But the idea was that you have corridors along which the goods are transported. And National Technical University here is involved in a project, EU project, which deals with this matter, and it's called Super Green. Now, the Super Green is such that gives emphasis on ways how those corridors are becoming green. And one of the means of turning a certain corridor green is to enhance the usage of LNG by everyone. By the trains, the trucks, the ships, the river ships, machinery imports, everything, to make sure that the impact is minimized. That means that we are expecting legislation in way of directives to come out and making mandatory that the country members of the EU provide bunkering stations, not only for ships, but also for trucks and trains, etc. So you can refuel. Now, one of the weak points of LNG is that actually the ship does not have the same range to sail as it does with oil bunkers. It has to refuel more frequently. How more frequently? It depends on the size of the storage tank for the fuel, but also in this case on the pressure under which you maintain it. Okay? As an exercise, we have run a test to see how often we would need, as a minimum, a bunkering facility to refuel an LNG fuel ship. And that has worked out something between 300 and 600 nautical miles. That would cover all ships. Now, as technology advances and you can have a longer voyage in front of you before you need to stop and refuel, that will change. But in the beginning, one needs an extensive network of bunkering stations. Piraeus has chosen to be among the first countries to promote LNG. And we are actually looking for ways where to put an LNG bunkering station. Where? It is not open to discussion yet, but I know researchers are trying to do a what-if analysis on possible locations. One thing we know is a bunkering station for LNG cannot be put inside the port. Okay, so which means all what you see in that picture is not allowed. Now, I think this bit here, which is an island in Italia. This small island on which we have all these water cleaning facilities on it might be a good place to also put a bunkering station for LNG because it's away from the city. Okay? And the reasons why Piraeus wants to do that is not only theoretical, as we have in Europe, that is for the abstract argument of having a cleaner atmosphere. We have a real problem with the ship's generators inside the port. There are many ships coming in and out. We have generators running on heavy fuel oil. And in summer, we have a big problem in the area of Piraeus port. So we have said, yes, we're going to do it, and hopefully we can encourage owners to consider it. It's not certain they are going to feed. Anyway, dates. Dates is 2015. Today we are 2013. Really, for that kind of measure, couple of years is tomorrow. By 2020, there is this global cup, which I don't believe it's going to come. With the experience of what will be in 1.5 years' time. And also, an open question as to who's going to pay for the conversion of the ships. I've heard that the EU is very concerned about this because they have realized that the money is a lot of money for a ship owner to decide it, which means it is rolling out everything except the very new ships. We have seen, however, the day before, that Norwegians have put together a NOx fund. The NOx fund is assisting ships to convert, etc., and paying quite a bit of the cost of. Would such an arrangement help in Europe? Yes, it would. Now, who's going to put the money to do that for EU-flagged vessels? I don't know. Maybe trans-European networks. Maybe. I mean, the only kind of budget that I know that could afford such a thing as this is a trans-European network. And yet, the bill would be very high. And how would that be apportioned? I don't know. You have big countries in the EU with few ships, and you have other small countries with big fleets. Now, who's going to get what? I don't know. It's getting very confusing. What is certain, however, is that it's going to have a colossal impact on short sea. And you see the various bullets there, and the outcome in red in the brackets. So let's take them one at a time. All ships, old plus expensive fuel because they cannot convert, means scrap. you lose it. Medium age and small cargo intake because it's a short sea ship, you don't have the money to retrofit in the first place. Many, I would say, would be scrapped. You lose the ships. If you don't scrap it, you sell it to somebody else outside a sector. All the rest will have to raise the freight rates to recover retrofitting or survive in a better market. Why will be the market better? The market will be better because there will be fewer ships. As simple as that. Which means that we move the supply curve so that fewer vessels are going to be available. What does that mean? If we have a demand curve which is like this, and the supply curve that is moving, like it specifies clearly there will be fewer cargoes transported at a higher price. Are the Norwegians concerned about this? Yes, we saw it the other day. They said it's going to be 10% more. 10% on the cost of goods imported and exported. 10%. That's a huge impact already. And if you're asking me, maybe the figure may be higher. I don't know what it's going to be. I don't want to make a bet, but maybe it can be even worse. The only ones that can do is the low-wage guys, hopefully, in a better market with higher cost, they will be able to survive, and new buildings. And I can have prediction here that ships, new ships, will be built with a dual fuel prediction anyway. Is it expensive to build a new ship? Is it more expensive to build a new ship and convert another one? The part that concerns fuel is substantially cheaper to build new, to introduce into a new ship from the design stage, the two fuels thing. Okay? But perhaps this is not all. We need to take into account some other general ideas. Those that are building the marine equipment for LNG and for scrubbers are going to have a good time. There are few shipyards to make the conversions in Europe. So we'll have to perhaps to do it elsewhere. We don't know. It's not the best time to take a loan from a bank to convert your share. We don't know much about the bunkering arrangements, who's going to build when, what. The only place in Europe we've seen that has got studded with LNG stations is the west coast of Norway. And we have the unresolved questions on safety during bunkering in ports, and that has to do with location. It's not the procedure which is dangerous, it is where you put the bunkering station, so as if something goes wrong, you will not have people burned as you have had in the past. So, what do we see? We see higher freight rates in the sectors. That is certain. And it's not a market distortion. It is something that it's a new situation. It's not that certain things interfere and with a given market have distortions. No, you have a different market structure. Okay? The guys from the marine equipment side are going to be very happy. And we're going to have a reversal of the road to sea initiative. Everybody has been blessing this. Now it's going to follow a negative direction. So what's going to happen when, after 2020, we have this becoming global? Then and only then there's going to be a bulge of orders from the short sea. Why? Because at the time the average age of the orbit of the short sea fleet will be near 40 years, or even higher, which means the combination of high age and having to run on expensive sulfur-free almost fuel means it doesn't make any sense to do it, so you will be obliged to build new. Where will you build them when there are no shipyards in Europe? I'll tell you, outside Europe. So this is going to be a bonanza for shipyards outside the EU. Why? Because shipyards within the EU are no more. And that is a small detail about the ports. The ports are not very much concerned about the bunkering station because for themselves it is not a big commercial decision. Why? Because the ports are hiring space. And to give the license to do this, they will put their specifications. It's going to be the individual who will be selling the fuel, as they do with oil. That will have to do the investment and see. Will people be forthcoming to do the LNG? The LNG bunkering station? I don't know. It's a big question mark. Because if you need to do this, you need, for example, say, to bunker 10 ships a day, and you only have 1 or 2 coming a day, then it is a disaster. Nobody is going to ask for the license. Unless we have an entirely different situation after 2020. And it says here at the end, after thinking, next time we'll examine the role of incentives. We haven't seen any incentives yet, have we, for all this? And what we said before, you can't have economic planning and policy drafting without having incentives. Okay? Next.
We finished.
We can carry on if you want, or we can finish here if you like.
We have half an hour.
We have.
If you are in the mood for talking.
As long as I have somebody to listen. If I'm talking to myself, it doesn't make any sense. Okay. Yes, over there. What are the other guys doing?
Yes. We have the University of Jacobs, Genoa, and Madrid.
No, are they there?
No. Let's ask them.
Ask them, are you there? Oh, yeah. Τι θες να κάνω?
Δεν έχει πρόβλημα, τι θέλει.
Νομίζω ότι τελειώσαμε. Okay. So, from what I understand, there are no questions coming from our friends in Genoa or in Madrid.
Jacobs.
In Jacobs, I beg your pardon. And in view of that, perhaps I would add a final comment. The introduction of legislation concerning the use of fuels is going to have very big impact on what we know today as international trade. And I'll make myself clear. When China and India have joined the World Trade Organization in 2003-2004, have given the sign of a big inflow of products from these regions to the United States and Europe. What is the reason behind that? The reason behind that was the lower production costs in India and China, which was several times lower than the equivalent costs in the United States and Europe. That meant that they were able to produce cheap things, which, with a small import duty or no import duty, would locate itself immediately to the markets of the West. Before, that is before 2003, this didn't happen because the countries of the West were putting import duty on these fuels. And they were roughly as expensive as those produced locally. Now, we are not talking about changing the rules of WTO. Assume we do not touch this. It is exactly as it is. Where will be the difference? The difference is going to be in the cost of transportation. For instance, if you are transporting goods from Shanghai by Piraeus, rather than from Valencia to Piraeus, and the distance is 10 times bigger between Shanghai and Piraeus, and it makes commercial sense, it will probably not make commercial sense if the cost of fuel is high. So rather than having the cost on top of the goods price imposed by the duty, the import duty, goods, the carrier has to face a much more expensive fuel bill, and that will replace the burden on the price of the goods previously imposed by the customs. Okay? Which means we're going to have an entirely new situation after we have a global low sulfur level for international trade and shipping. That will change things vastly from the ground up. And it's too early to have any idea what it is going to be. Men do not have the ability to see what the future comes, what it brings when it comes. But one thing is certain, that sea transportation is not going to stay as cheap as it is today. Soon, that is going to be a thing of the past. And that is going to change more or less everything around marine transportation. And with these comments, I call it a day. Thank you very much.